What's up, Math 6 students? Chapter 8, Section 3, Surface Area of Pyramids. And the essential question for today, how do I find the area of all the faces on a pyramid? All right, that's surface area, by the way. You find the area of all of the faces on the pyramid and you add them together, you get the surface area. So the key idea here is that we're going to take for instance, square pyramid or rectangular, well, in this case, square pyramid. A square pyramid is a pyramid with a square base. Remember, unlike a prism, the base of a pyramid, in this case a square, does not have a square that's identical and parallel on the top. It just has a vertex. So if you take this base and the triangles which are attached to it, and as you can see, there are 4 triangles attached to this base. You have a triangle that's attached here on this edge. You have a triangle that's attached here on this edge, so the triangle that's right here, right? And then you have a triangle that's on the back, right? And a triangle on the left side. So to see that more clearly, we're going to take this and unfold it. You can see one triangle here, one triangle here, one triangle in the back, and one triangle here. And when you're done, you have the base on the bottom, and then you have the 4 triangles on the sides. These triangles have a name. They're called lateral triangles, lateral triangles. And if you have a square base that has 1 side, 2 sides, 3 sides, 4 sides, there are going to be 4 lateral triangles, one attached to each edge of the base. Okay, how about a triangular pyramid? And this net word, I know some people have gotten confused by that. A net is just taking the 3-dimensional shape and unfolding it so it's flat. And so this here, this flat version of the square pyramid is a net. So same thing here. A triangular pyramid is a pyramid with a triangular base. Okay, so the base is a triangle. If the base is a triangle, how many lateral faces are there? Well, there's 1 attached to each side of the base. So 1 lateral triangle, 1 lateral triangle, and then 1 in the back. That's 3 lateral triangles. 1, 2, 3. And then, of course, you also have the triangle on the bottom. So you have the base triangle, which is in the bottom, and then you have your 3 lateral triangles. Cool, that will help us. So if we're finding the area of every single face, those lateral triangles, I don't know if you can see this, but they are all the same if the base is a square. And these lateral triangles are all the same if the base, this triangle, is an equilateral triangle. That means that every single side is the exact same length. Let's hope that we get a lot of problems with squares and equilateral triangles as the bases, because then it will make our job easier. Okay, let's try an example. How do I find the surface area of a rectangular pyramid? And really what we're actually doing here is a square pyramid. We're doing a square pyramid because a rectangle is actually harder. With a square pyramid, the base is a square. That means all of the triangles, if this is a square, that means all of the lateral triangles are the same because their bases are the same length, okay, because this is a square. So it says, find the surface area of the square pyramid. Aha, it is a square. That means the base is a square. Okay, they've already made the net here. So here's our base. Remember, if it's a square, each side of the square is the same length. So they're both 7 meters. That means these 2 triangles, these 2 lateral triangles, are congruent. That means they're the same exact triangle twice. So if we're finding the surface area, SA, surface area, we can start with the base. Well, the base is a what? It's a square. How do you find the area of a square? Isn't it just like, wouldn't it just be length times width or base times height? Wouldn't that just be 7 times 7? Yeah, that would give us the area of the base, but that's not the surface area. The surface area would be not only the area of the base, or the bottom in this case, but the area also of all the triangles, the lateral triangles. And because this is a square, all of these triangles are the same. So what I'm going to do is I'm going to add more area, right? It's going to take more squares to cover the entire thing. I'm going to leave a factor that we're going to multiply by there. And right here, inside the parentheses, only write the area of the triangle formula. So how long is this side? This side is 7. And the perpendicular height is 10. So it's a triangle where the base is 7 and the height is 10. I know what you want to do. I know you want to go 7 times 10. But you can't. It's a triangle. And a triangle is half the area of a rectangle. So it's 7 times 10 divided by 2. And that 7's not the best 7 I've ever made. Oh, neither is that one. Oh, it's not bad, though. It's okay. So it's 7 times the perpendicular height 10 divided by 2, because it's a triangle. Students, when they are finding the area of the base, sometimes they divide by 2 when it's a square. No, don't do that. Or they forget to divide by 2 when it's a triangle. Don't do that either. But now, what was this factor that I left here? How many lateral triangles are there? Well, it's a square base, which has 4 sides. So there are 4 lateral triangles. So we're going to multiply the area of one of the triangles, right? One of the triangles would just be the area here. But if we multiply it by 4, we get the area of all of the triangles, how many square meters it would take to cover all the triangles, which is awesome. Okay, line down the middle equals 7 times 7, 49, plus. And I have some students who say, well, I like to figure out what the value is in the parentheses and then multiply by 4. I have other students who are all super like, Mr. Plunkett, I can see that that 4 is really 4 over 1, and it's multiplying another fraction inside the parentheses. And I can see that the 2 and the 4 are going to cross cancel. Either way, you end up getting the same value. So if you'd done 7 times 10, that's 70 divided by 2, that's 35. And then you do 35 times 4, and what is that, 140? Well, we should get the same thing here. So equals 49. I probably should have given myself more room, but that's okay. 1 times 1, that's just a 1 in the denominator. But 2 times, well, I guess 7 times 10 is 70 times 2. Yep, that's 140. We add those together, I get 189 meters squared. It's area after all, surface area. Area is square area. So what does this mean? This means it would take 189. If I had a square meter, okay, 1 meter on each side, you can see it's a beautiful square. It's so straight on each side. Wow, I'm impressed. If you took a square meter, it would take, and that's drawn too big, but it would take 149 of them to cover all of the triangular lateral faces and the square base. It would take 149 square meters to cover this whole thing. Okay, to find the area of a square pyramid, or I guess I should say surface area, huh? I'll fix it for yours, but for mine it's off. Find the surface area of a square pyramid, we add up the area of all of its faces. A square pyramid has how many faces? Well, it has the base, and then there's 4 triangular faces, lateral faces. So a square pyramid has 5 faces. The lateral faces, remember, the lateral faces, those are the triangles. Those are the triangles, not the base. Even if the base is a triangle, the lateral face is just referring to these triangles that are surrounding the base. In a pyramid are always triangles. I guess that was redundant. But you get the point. Careful to always use a base and a height of the triangle that are what? Remember, this right angle box, and I didn't mention it a minute ago, but if this is 7 and this is 10, right, you need to use dimensions which are perpendicular. So that right angle box tells us those are perpendicular. Cool. That ends part 1 of this video. I'll see you in just a second for part 2.